I'll start with F. What do you expect the splitting to be? Do we all agree?
Yes.
Because the neighboring hydrogens, there are two of them.
Didn't see that.
Everybody okay? Let's start with another simpler one, B. What do you expect for B?
Three.
Are
No,
you sure?
No.
It has only one neighboring hydrogen.
So it's a two.
Doublet. Oh, is that, I didn't hear that. I heard what Carter said. I didn't hear what you said. We good, everybody?
Yes.
What about A? I'm getting the relatively easier ones out of the way. What about A? So again, there's only one hydrogen on the atom next to it, so we expect to see a doublet, although with OHs generally because of intermolecular hydrogen bonding, we lose multiplicity information, but at least that's our expectation for now. Are we good?
Mm-hmm.
Now let's talk about C. Is C going to couple with B?
Yep.
Is C going to couple with A?
No.
If I'm holding your hand, are you not holding mine? If A is coupling to C, then shouldn't C couple to A? It's a mutual interaction, right?
Yeah,
If
so
this
yeah.
nucleus is coupling with the other one, then pretty logical that this one's coupling to that. That makes sense? So coming back, is C coupling with B?
Yep.
Is C coupling with A?
Yep.
Is C coupling with D and E?
Yes.
So what is the, yes, absolutely. So what should be the coupling or the splitting for C?
7.
So 1 plus 3, assuming they're the same, we're not doing complex. 1 plus 3, 4 plus 2.
Is 6.
So what should it be?
6.
Again, right? 6 plus 1, 1, 2, 3,
6
4,
plus
5,
1
6.
is 7.
Okay? Everybody?
Yep.
Okay, what about E and D? Let's take them one at a time. What do you expect for D? Is D, sorry? Okay, is D coupling with F? Does D couple with F?
Yeah.
Does D couple with C? Does D couple with E? Absolutely. It's only 2 sigma bonds away.
Yeah.
They're not identical, they're actually different from each other. Agreed?
Yeah.
So who is D coupling with? D is with C, with F, and E. So what is the multiplicity for D? What's the total number of H's? 3 plus 1?
3,
4
4.
plus
1 is
1.
5.
So do you agree? At least that's our expectation. We're only writing our expectations here. Then what about E? What do you expect for that?
Same.
Okay. Is everyone okay? Yes? Let's do this faster, guys. Because I want to finish this today so that when we come back on Wednesday, we actually look at spectra. We try and analyze actual NMR spectra. Let's look at this. How many signals did you say? 4. A,
Yeah, I got 4.
B,
At
C,
least I got that.
D. Did I do that correctly?
Yes.
Okay, let's start with A. Multiplicity. Careful. Careful.
2.
For A, you're looking at neighbors.
2.
Doublet? Do you all agree? There's only one hydrogen at C. What about C? Quartet?
4.
Quartet?
4
Because C is
plus-
coupling with A. There's nothing there.
3 plus 1.
No hydrogens there. What about B? Singlet, because it has 0 neighboring hydrogens. We good? What about D?
Singlet.
As well.
1.
Are we all okay? Okay, next one, how many signals?
Oh.
I heard 3. No, 3. Those 2 methyls are not the same. There's no symmetry in this molecule.
Yeah.
Okay, multiplicity for A.
Singlet.
1.
How about B? How about C?
Triplet.
Why the question mark at the end?
I don't know. I'm the only one talking.
Good. Everybody okay?
Yeah.
Yes. Let's look at next one. How many signals?
5.
5. So what are those 5?
Two H's after the double bond.
So these are diastereotopic hydrogens,
Yep.
C, D, and E.
Yeah.
Okay, let's start with multiplicity for A. Is A going to couple with B?
Yes.
Absolutely. Actually, pretty large coupling. Is A going to couple to C?
Yes.
How about D?
No.
At least for all practical, actually it will, but we are not going there. Again, that's the long range coupling thing that I keep talking about. It makes things a little bit more complex than what we are presented here with. So we are not, unless you're looking at benzene, just stick to 3 sigma bonds max. So is A coupling to B? Yes. To C, yes, but D we can leave it for now. So what is do you think AB coupling will be equally strong as AC coupling?
No.
So what should be the multiplicity for A?
Oh, 2. 2 squared.
Because those couplings are very different from each other. It's a doublet of a doublet. What about B? Is B coupling with A?
Yes.
Is B coupling with C?
Yeah.
Do you expect AB coupling to be the same as BC coupling?
No.
So what would be the multiplicity for B?
2 squared.
2 squared.
Doublet of a doublet.
Okay, don't do 2 squared because we don't
Oh.
use that symbolism. We use this symbolism, so please stick to that. Now C is very complex actually if you really think about it, because is C going to couple to A? Is C coupling with B?
Yeah.
But then is C also coupling with D?
Yeah.
So it's a very complex multiplicity pattern because all the couplings are very different from each other. So it's actually very complex multiplicity pattern. For CD, what do you expect the multiplicity be for this coupling to be?
Triplet.
Do you agree?
Yes.
And then CA? What about CA? And what about CB? Probably going to see a very complex pattern over there in that part of the spectrum, which it'll look like a mess of signals because they're all kind of sitting on top of each other. Okay, let's get to D though.
Wait.
Is D coupling with C?
Yeah.
Is D coupling with E? No, too far away. Is it? 1, 2, no, it's not. Here's the H. 1, 2, 3 sigma bonds.
Yeah.
So let's try that again. Is D coupling with C?
Yeah.
Is D coupling with E?
Yeah.
But is DC equal to DE?
No.
Is it?
Oh, yeah.
It is.
Yeah, they're just signal.
Yeah.
When there's pi bonds. Okay, fine. So what is the coupling? What's the multiplicity? The J values, the coupling constant values are bound to be a little different. But what do you expect it to be, the multiplicity for D to be, if it's coupling with C and E? I would expect doublet of a doublet, but if you gave me triplet, I will take it. Because again, doublet of a doublet requires a little bit of a deeper knowledge, which again, we're not getting into that amount of depth. If you gave me this or you gave me that, I'm happy. As long as you're recognizing that, okay, there is coupling with C and there's coupling with E as well.
Oh.
I'll take it. We good? What about E?
Triplet.
Sounds okay? Everybody? Okay, let's go to the next one. How many signals?
5 signals.
I heard 5 signals, so let's see. So A, B, C, D, and E. Did I get that right?
You checked out.
Yeah.
Okay, multiplicity for A.
I can tell.
Triplet.
Everybody okay? Triplet? How about B?
Quartet.
How about C?
Singlet.
How about 1, 2, 3, 4? Okay, how about D? Because that's 4 atoms away, bonds away. How about E?
Singlet.
Everybody okay?
Yep.
Let's go to the 3 benzene structures here, just for a better understanding of benzene. Benzene is the only time we will go more than 3 sigma bonds, 4 sigma bonds, basically. So how many signals for this structure?
4.
I heard 4. So because it's not symmetrical, right? Okay. Multiplicity for A. Is A going to couple with B?
Yes.
Yeah.
How about A and C?
Yes.
How about A and D?
Yes.
No.
No.
Is AB the same as AC?
No.
So what do we expect for A? Doublet or for doublet?
Yes, that one. I wrote that down.
Do you agree?
Sure.
Everybody?
Yeah.
Okay, how about B? Is B coupling with A?
Yeah.
Is B coupling with C?
Yeah.
Do you expect A, B and BC to be about the same or different?
About the same.
About the same, right? So because they're going to be about the same, what do you expect A, B and BC to result in?
Triplet.
Because
yeah.
there are 2, right?
Yeah.
But then what about B coupling with D? Is that possible?
Yes.
And is that the same as the others?
No.
So what should happen to the triplet?
Triplet of a doublet.
We'll split in 2 more. Triplet of a doublet.
So is there a triplet of a doublet or a doublet of a
Who
triplet?
cares?
Okay, sure.
Generally, the convention is the bigger coupling comes first,
Okay.
conventionally,
Okay.
and then the smaller coupling comes after. We good, everybody? Oh, we didn't finish. What about C?
Triplet of a doublet.
Same story as B?
Yeah.
Everybody with me?
Mhm.
How about D?
Doublet of a doublet.
It's coupling with this and this, but not that. Everybody okay? Yes?
Could you show us what a triplet doublet looks like?
I can try.
Okay.
Ideally speaking, again, that depends on the compound and the machine's, the instrument's resolution. If you were doing it upstairs, you will just see a blob, because we don't have but if you had a decent instrument. So first this is your signal. Okay. And that signal gets split into a triplet first. So keeping the chemical shift the same.
Yep.
And the integration is the same. So that area gets split into 3 parts. And then each of those gets split into a doublet.
Each one of those gets split into 2 parts.
So what you ideally see is that, but will you always see that? No. Because what if these overlapped? Or, all of those things. So, but that's an ideal picture, if that helps. So what you will see, and by the way, I'm drawing these upside down. Okay, fine. So you will see, ideally speaking, you will see a splitting pattern like that. But then don't be surprised if these lines overlap each other and intersect, then things get complicated. Does that answer your question, Erin? Okay, cool. Let's go to the next one, guys. How many signals?
4
4.
signals.
Let's see, A, B, C, D. Did I do that right? Okay, multiplicity for A.
Little triplet.
Do you agree? Because A couples with B and D, but not C.
Yeah.
How about B? Will B couple with C?
Yeah.
What would that be? Multiplicity. What would the multiplicity be for that?
Doublet.
Will B couple with A?
Doublet.
Will B couple with D?
Yes.
Do you expect A, B and BD to be about the same?
Yes.
About the same. Will they be exactly the same? No, because these guys have an effect on it too. So what should we expect the multiplicity for B to be? Doublet of a triplet or triplet of a doublet. Again, since the doublet is bigger, I'm writing that first. We good, everybody?
Okay, no, I didn't, never
Oh.
mind. You meant,
The bigger in terms of coupling. The
okay, I thought you
stronger
meant
coupling.
amount of.
Oh,
Yeah,
no,
I
sorry,
think it-
sorry,
yeah.
sorry.
Okay. That
The
makes way
bigger
more sense
coupling
then.
means the strength of the coupling.
Okay,
So
that's what I
whichever
thought.
couples stronger, like that.
Cool.
How about C? What do we expect for C?
Couples to B and D.
C couples to B and D, but what about A? Does it couple with A?
No.
Okay, so what do you expect the multiplicity to be?
Triplet.
Do you all agree?
Yeah.
Okay, how about D?
Same thing.
Same as what?
B.
So D couples with C, that's bigger,
Yeah.
stronger,
Yeah.
stronger. And then it also couples with B and A, which are weaker. So doublet of a triplet. Everybody okay? Everybody okay? It takes practice, and that's why there's so many repetitious examples on the handout. You go through it one at a time, one at a time, one at a time. Okay, how many signals?
Yeah.
Louder? Two. Agreed?
Yep.
Signal multiplicity for A. Doublet. How about multiplicity for B? Also. Is it starting to sort of make sense? Of course, you got to go through it over and over again till it really sinks in. Now, I want to point your attention to some hints when we start looking at actual proton spectra in Wednesday's class. Some patterns to pick up on. And I've written those down here. Whenever there is an isolated, what group is this, by the way? See,
Alpha.
ethyl group. Whenever there's an isolated ethyl group, meaning it's not coupling with anything here, what do you expect the ratio integration to be? Integration ratio for these two? What
2
would
to
that be?
3.
2 to 3,
Yeah.
right? And what multiplicity do you expect for this signal to have?
Quartet.
And what do you expect this to be?
Triplet.
It's a very interesting pattern that we see, that if you see a quartet and a triplet integrating for 2 and 3, oh, is there an ethyl somewhere? So it helps the process of assimilating data a little bit easier. So be on a lookout for that. If you see quartet, triplet integrating for 2:3, it most likely means there's an ethyl there. Similarly, a propyl group, same thing. Can you tell me what would be the integration ratios if you go left to right?
2 to 3.
2 to 3, and what would be the multiplicities going left to right?
Quartet.
Careful.
Triplet.
Triplet.
True. No.
It has 2 here, 3 there.
5.
Quartet.
Plus 1,
6.
Oh, 6.
Sextet.
Oh, that's right.
and what would that be? Oh, it has only 2 neighboring. That's too far away.
Doublet.
3 sigma bonds only, please. Doublet. Please, let's take a look carefully.
Oh, triplet.
So if you see, and again, these are the patterns you might notice in those spectra which make the process easier. If you see 3 signals, 2 to 2 to 3 ratio with a triplet and a sextet and a triplet, oh, is there a propyl group somewhere? And this is very interesting because this is really, I love this one. How many signals for this piece only? Just for the isopropyl group? Sorry?
2 signals.
2, right? 1 and 2? What do you expect the integrations to be?
3 to
Not
1.
3. 6 to 1.
6 to
Let's say
1.
1 to 6. 1 for this and 6 for that. Agree?
Mm-hmm.
What do you expect this guy's multiplicity to be?
1 plus 6 is 7. Septet.
So if you see a septet, and what about these methyls? What do we expect that multiplicity to be?
Doublet.
Very, very clean patterns. If you see a septet and a doublet integrating for 1:6, that's an indication of an isopropyl group. Really helps. Lastly, that will also be a very common pattern for us to catch on to when you have 1,4-disubstituted benzene. So you have whatever X is, whatever Y is. How many proton signals should I see here? Do you agree? 2?
Yep, 2 signals.
And what would be their integrations?
1 to 1 to 1. 2 to 2.
Or, right? Do you agree?
1.
2 to 2 or 1 to 1, whatever, however you look at it. However you look at it, but the point is 2 hydrogens, right?
Mm-hmm.
And what about the multiplicity? What do you expect? Louder? Exactly. It's a very clean pattern. You see two doublets integrating equally in that benzene region of the spectrum. Ooh, is there a 1,4-disubstituted benzene in this compound? So some of these structural patterns that give us hints that help the process easier. So keep an eye on for that. Now I think we'll stop here, but what I would like to encourage everybody to do between now and Wednesday, because there's no exam tomorrow, right? Of course.
There's an
There-
exam.
no, it's just between sessions.